Okay, so far we discussed about source of drain and various plumbing fixtures. Now we will talk about drainage fixture unit calculations. Okay, how to do the calculations, and based on that calculation, you can able to size the pipes, right? Based on the drainage fixture unit calculation. Okay, so if you go to International Plumbing Code, okay, say for example chapter 7, right? If we go to chapter 7, you have a sanitary drainage. This is what last week we have gone through the complete codes and standards, right? Okay. If you go to the standards uh, for the drainage fixture unit sizing. So here we have seen the drainage fixture unit fixtures and groups, right? You have a different type of fixtures. Okay. Say for example, I have one of the layout. Okay. Let me open one of the layout. So here it is given in the each and every category. Okay, the drainage fixture unit calculations, right? So if I open one of the drawing in AutoCAD, so here we have seen last week that one of the toilet, right? So here what is our aim? Say for example, you have a very very big projects, okay, and understand that this is your final manhole from authority, which is called FIC, right? So what is your aim? You will direct the pipe towards this discharge, okay. However, you will run whatever the directions, you will directly, it is like a flowing of water to the drainage, right, by means of gravity. So how you will do? From here to your direction should be here, from here to here your direction should be here, right, from here to your direction should be here. So that is our aim, okay. We have to achieve as far as to go with the gravity pipe, okay. If you cannot go with the gravity pipe, then you have to go with the forced type, which is called sump pump. If you go with sump pump, you are increasing the project cost, okay. So you have to try to avoid by using best design by means of gravity, right? Say for example, if I use this one, right, if this is the toilet, one of the toilet. So how to do the calculation for the WFU? There is a calculation sheet, okay. Based on this calculation sheet, you have you have a drainage fixture unit calculation based on IPC, right? You have a different plumbing fixtures, okay, fixture type, right? Bathroom group, kitchen sink, okay. Then you have a urinal. There are different type of uh, fixtures, okay. So this quantity you are going to enter the quantity based on the project, right? For example, I have a 1, 2, 3, 4 urinal or 4 WC, okay. Go to the Excel sheet and enter 4 WC here. This is the flush tank, right? So you will enter 4 WC. You will get total 20 DFU, right? This is your DFU calculation. Okay. Now what is the next step? Either you have to go to local codes or international standard codes, right? So if you go to international standard, you can able to calculate the pipe size. This is the horizontal fixture branches. Okay, for 20 WFU. So if I go to total for horizontal branches, 20 WFU, I have to go with the 3-inch pipes, right? Correct? 3-inch pipe for this particular fixture. Okay, but I will go to local standard. What it says for the wastewater pipe, I have to use minimum of 100 mm, right? Say for example, if I go to the local standard, okay, for the WC I will be using 100 mm, right, as a minimum. Clear, right? Say for example, if I go to each and every pipe, for the soil pipe 100 mm, wastewater pipe 100 mm, okay, and rainwater pipe I have to go with 100 mm. This is the minimum, okay. So even though if my IPC value say that 3 inch, which is 75 mm, I cannot use that one because I have to follow my local standard. So I have to follow with the 100 mm branch, right? Okay, so that is what you can see in this particular layout. If I have a WC here, this is the outlet from the WC. Then when I follow below, if I go to further this layout, Yeah, I can see this particular drawings, right? I can see that this is the WC, the same toilet below. Okay, that is the above, this is the below. So you can see that there is a WC, the pipes from WC, right? The pipes from WC. Okay, and what is the header? This is the header, 100 soil pipe. Okay, so even though if my standard says 75 I will follow as per local code, which is 100 Okay, so this is the calculation for the as per the DFU. Based on the DFU calculation, I will find out the pipe sizes. Okay, so what are all the soil pipes? When I say soil pipe, I can connect WC and also the urinal, right? Okay, so I'll be connecting all the urinals here. Okay, so if I go to my IPC standard, if I go for the urinal, right? What is the value for fixture? Okay, so I will go to my Excel sheet and I will enter how many urinals in the project. Say for example, this is my urinal. Okay, okay. This depends upon the project. Whatever I have, like I may have a flush tank, right? I may have a flush valve or flush valve. Normally, we have a urinal with sometime with the flush tank, right? Okay, so when you after usage, you will flush it. Then there is a water will come from that particular tank. Okay, inside there is an inbuilt tank. Okay, so normally we have a flush tank method. The flush valve will be normally in other countries. Okay, so if I go how many WC in my project, say for example 1, 2, 3, 4, 5 WC or urinal. Okay, so I will go to my Excel sheet. I will enter 5 urinal. So I can able to calculate how many DFU here, right? This is my total fixture unit, which is 35. So if I go to the standard again, I can able to check what is a 35. Say for example 20 to 160, I have to go with the 4-inch pipe, right? Clear, right? Riyaz, Ajit?
Yes, sir.
Okay, so up to 160, I can go with 4-inch pipe. Okay, whatever the fixtures, I will be adding, keep on adding up to 4-inch, I can add up to 160 DFU, basically, right? So if I go to this particular sheet, based on 5 urinal and based on 4 WC, my total fixture unit is 35. So up to 35, like this is the between the value 20 to 160. So maximum, like I can use 4-inch pipes. So if I go to my layout, I can see that each and every branch will be as per the fixture pipe size, fixture connecting pipe size. So what is the fixture connecting pipe size? If I go to my Dubai building code, I can able to see the fixture sanitary fittings, minimum outlet size for the fixtures, minimum sanitary fitting outlet size. So if I go to WC 100 if I go to wash basin 32 right? Kitchen sink 40 Okay, urinal is not given here, but we can follow as per the manufacturer, right? The manufacturer will be normally for the urinal, you can say like 50 or 75 correct? Aditya, the urinal pipe size
50
will be
sir.
50 right?
50.
Yeah, 50 Okay, so that is from the fixture outlet. Okay, like if you are going with a different type of urinal, that you have to follow as per the manufacturer standard, right? So you can use that fixtures here. Okay, when you calculate all the pipe size, the header will be 100 right? Then you will go further down. Okay, what is our aim to reach to the final destination? Okay, then you have some more WCs here. Okay, some more fixtures in this area. Okay, as I can see that there are WCs, right? If I go to the other layout, if I go to this layout, I can see some more WCs here. Okay, so these all WC and whatever the yeah, here only WC. There is no urinal here, right? Because it is a female toilet, right? There is a male toilet and female toilet. So we are going to collect all the water from waste soil water from that area, and based on the calculation from here and from here, we are going to direct to the shaft. right? Clear, right?
Yes, yes.
Okay, so normally if you go here, you can see the shaft here, 75 wet pipe, vent pipe, then 150 waste pipe, 150 soil pipe, right? So if I go to my code, okay, what they are saying for the up to 7 story, you can go with the soil pipe 100 only, right? And you can go with 100 for the waste pipe itself, okay. But some project, some consultant, they design with oversize, right? For example, to avoid the blockage, they may go with the higher size, which is 150. See here, 150. Actually, this building is less than 7 story. Okay, but still, some of the consultant they go with the higher pipe size because to avoid any blockage. Okay, say for example, this is a business. This is the supermarket. Okay, the business will be overcrowded, right? Some of the time. So to avoid that, they have sized oversized, right? But as per the standard 100 only, but you can go with the like the which much higher pipe size to avoid any blockages. Okay, so here you can say waste pipe how much 150, then soil pipe 150. Okay, to calculate all the soil pipes you can put all the fixtures, whatever the soil fixtures quantity you can enter it here, then you will get the total drainage fixture unit for soil pipe. Okay, if you enter all the waste pipe come from where? From shower, from lavatory, right? From bidet. Bidet also will be considered as a soil pipe, right? Then bathroom group. Okay, then you can say like even kitchen sink as well. Before the after the grease interceptor, it will be connected to the your waste pipe. Clear, right? So here, if you go to the drawing, you have to calculate how many fixtures. Say, for example, if I go to my toilet area, I have to calculate how many fixtures in that area, right? So here I will see how many fixtures like ablution area. It will go to the waste. Okay, you have to segregate. Okay, here I have a wash basin, so it will go to the waste. Here I have a urinal, it will go to the soil, and I have a urinal here, it will go to the soil, right? Here I have a wash basin. So each and every toilet I have a flow drain. If I have a surface drain, it will be connected by means of flow drain, right? Okay. So this flow drain and the wash basin will be connected to the wastewater pipe in the riser, right? So here I will be connecting all the pipes here. So because this is the gravity pipe, there is no any pressure calculations, no need of any hydraulic calculation is required. This is directly from based on your DFU or based on the local standard, you can able to convert the pipe size. Okay, so if I see further down, okay, assume that this is my riser, right? If I go here, this is my riser. Okay, I'm collecting all the pipes here. I'm collecting all the pipes here. So similarly, you will collect the pipes from everywhere. Say for example, if I have a shop, okay, in the shop I have a catch basin, for example, right? Each and every shop I have a catch basin. Okay, so this all the wastewater will be collected, and it will be directed towards the shaft, right? You can see that shaft here. Okay, it is going to the shaft. You have to find out the shaft. So when you are working with a consultant, the location of the shaft is very important to identify the shaft location. Okay, which help. Say for example, if you instead of providing the shaft here, maybe if you provide the shaft somewhere else, maybe you cannot able to achieve the invert level. Okay, so the location of the shaft is very important to achieve the invert level, basically. Okay, say for example, what is the purpose? Assume that I have a shaft somewhere here, right? Assume like that. Okay, what will happen? The slope will be increased from here to here. Maybe sometime you may not able to achieve the false ceiling level, right? So to reduce your level, you have to identify the nearest shaft location where it is possible. Say for example, you will collect all the waste here, then you will go to the nearest shaft. Okay, then you will collect all the shaft here. Maybe you will try to find out nearest shaft here. See for example, this is the shaft. You are collecting all the waste, whatever the waste in that surrounding area. Okay, so this is the purpose. So you are going to collect all the waste from that particular area. See, this is the CDP, condensate drain pipe, right? The condensate drain pipe from the equipments, from HVAC equipment, based on the air on coil and air off coil temperature. That we will do the calculation, how to calculate the condensate drain pipe for the HVAC equipment. What is the condensate drain flow? So based on the condensate drain flow, you can able to calculate the pipe size based on the standard, right? So this all waste from the condensate from the HVAC equipments. Condensate drain from HVAC equipments. Basically, you can see this is AHU and you have a condensate drain. This is the FCU. You have a condensate drain, right? Okay, so this is one of the waste pipe, condensate drain pipe. Okay, then in each and every shop you have catch basin, like this is the kiosk area. Okay, you have a catch basin, right? So this all the wastewater will be directly directed towards the shaft, nearest the shaft. Okay, for the to design all the catch basin or flow drain, you have a standard given here. Okay, say for example, I have if you go to here, say for example, sometime you can consider as a service sink, right? Okay, sometimes there is a hose bib is there.
For catch basin, DFU is given.
If I go to standard, let me see what is the value given here. See, it is given here. Can you see that flow drains? It is called flow drain, right?
Yes, but the sizes of catch basin start from 110. Floor drain usually from 75 mm.
Yeah, flow drain is 75 mm. Basically speaking, there is no standard given in the catch basin, but we can refer with the manufacturer. If the manufacturer designed for 110 mm, that means you have a directly the pipe size, right? The minimum pipe size from the trap. See, if you go to further down, the standard they have givenly mentioned here. Okay. You can see the for the purpose of competing loads on the building drain and sewers, water closet and urinal shall not be rated at lower drainage fixture unit unless the lower values are confirmed by testing. Trap size shall be consistent with the fixture outlet size, right? Okay, so when you go to catch basin, they have calculated for 110 mm pipe size. So the flow rate will be depends on 110 mm. So that is why directly the pipe size is arrived, right? Okay, you can see.
I have one question.
Yeah, yeah.
While pipe sizing of floor drain usually 75 mm we take 75 mm from outlet.
Okay.
Okay, and after how many branch connection the 75 mm will convert to 110?
Yeah. See, that is what you have a flow drain. What is the DFU value? 2 mm. 2, right? 2 is the value. Okay. So if I go to international standard, okay, what is that? What it is saying? Up to, say for example, I have a 10 flow drain. Assume the 10 flow drain. Okay. So 10 into 2, how much? 20, right? So up to 10 flow drain, I can connect with a 3-inch pipe, which is you can say 75 mm, right?
But it depends on buildings also, na? Like peak, like as we said, every time it will not be occupied. Like peak interval and normal interval of usage.
Or okay, see the flow drain where you will be using it normally in the for the surface drain, right? Okay,
Yeah,
yeah, okay. Now,
bathroom,
yeah. Say for example in
hotels,
bathroom.
bathroom.
Okay, in
Yeah,
hotel mainly in the bathroom. Okay, flow drains.
yeah.
Okay, so this flow drain the usage will be say for example if I go to toilet. Okay, assume that I have only 4 toilet or 5 toilet, right?
Mm-hmm.
Okay, assume that all the 5 toilet will not be in use, right?
Yeah.
Okay, so it is a probable method. That is what I said for the plumbing, water supply, and drainage. It is a probable method. Okay, so that is why the maximum the drainage pipe will be based on the fixture or based on the outlet size, which is 175 mm as a minimum, right? To avoid any blockages. Okay, so assume that you can connect a 20 flow drain in one pipe size. Assume that I can see. Okay, some of the consultant what they will do, they will just
20
oversize
DFU.
20 DFU up to 20 DFU.
Yeah, means
Okay, you can go with the 75 mm.
5. Okay, okay.
Okay, if you go more than practically, okay, if you go more than 20 DFU, then you can go with 4-inch, right? For horizontal drain pipes.
Mm-hmm.
Okay, but some consultant what they will do, they will just for safety purpose or based on the previous project experience, they will just oversize the flow drain, because if you oversize the flow drain, nothing going to happen, because it will easy flow of the pipe, right? Only the project cost will
Oversize,
increase. Say for example,
oversize
I will
floor drain means.
oversize means you will go to the next size. Say for example, I will tell you as an example, right? Say for
Okay.
example, here you have a flow drain. How much pipe size? 75 mm. Up to here you have a
Yeah.
75 mm. This is
Yes.
also 75 mm, right?
Yeah.
This is also 75 mm. Okay. But when you see the header, say for example, I will see the header here. Here you can see the waste pipe. Also they have designed with 100, right?
Mm-hmm.
Okay. Now you have a trench drain. Assume that I have a ablution area. Okay. Ablution area. Here I have ablution area that also connected to the waste drain pipe, right? So here if I
Yeah.
calculate WFU, I will go to my Excel sheet. Okay. If I go to this Excel sheet, I'm going to calculate what is the total DFU, right? So how many flow drain? 1, 2, 3 flow drain. Assume, right? So I can go here. Uh, Sorry, the flow drain value is not given here, but we can add it because this is as per IPC only. Okay. I will add one flow drain here. Okay. What is the flow drain value as per IPC? Flow drains 2 DFU, right? So I
Yeah.
will provide 2 DFU here. Okay. So what is the total DF flow drain? Three
2.
numbers. Three numbers. 1, 2, 3, right? And how many flow drain for the
2.
corridor? If you go to the plan, you will understand. This is like corridor, right? In the in the
3.
in the toilet corridor, right? So I have a two flow drain here again. So here again I have a one more flow drain here. So total 1,
6.
2, 3, 4, 5, 6 flow drain. So I will provide 6 flow drain, right? Okay.
Mm-hmm.
Then I have here kitchen sink. Sorry, ablution area. So if I go to the plan, I can see how many ablution area, right? If I go here, I will see that how many is there? 1, 1, 2, 3, 4, 4 WC area, right? 4 ablution area, right? So if I go to my IPC code, can I consider that it is a sink? It is a sink or service sink? Can I say like that?
For ovulation, they will give separate DFU, no? Not given.
Separate, yeah, yeah. Sometimes some codes it is given here, but in this standard I couldn't find. Right, this is the IPC
Uh,
standard. I cannot find
okay.
any, so I can consider the nearest one, right? Okay, so
Service.
let him, yeah, yeah. Let me see. Let me say that it is like a servicing, right? Okay, so I have a two DFU for the servicing. Again, I have a 4. As per this, it's only 2. So I can go with the 4 ablution area. So I have a total of 8 DFU, right? So if I
Mm-hmm.
add it together, I can say that it comes around 20 DFU as a
Uh,
practice, right? So since what as a designer, what they can do, since it is close to the final value, right? So close to the next value, so they will consider as next pipe size. See here, up to it's very neck to neck. Okay, to take a safety, they will go with the 4-inch instead of 3-inch. Up to 20 DFU, you can go with the 3-inch, but just for safety purpose, they will go with the 4-inch, because if you go with the 3-inch, maybe there is a chance of blockage. So they will go with the 4-inch. So that is why you can see in this diagram as a 4-inch pipe, right? Okay, you can see as a 4-inch pipe, right? So this 4-inch pipe, then this 4-inch pipe, whatever the pipe size here, it will come and this will go to the riser to the lowest floor, right? Is it clear, Rias and Ajit?
Yes, sir.
Okay, so basically we are calculating the DFU to determine the pipe size. Okay, the pipe size should be the best pipe size to match with the fixture and also to match with the local codes and also to avoid any blockages. Still, you can go with a little bit higher size. It's not a problem. Say, for example, I have a 100 mm from WC, 100 mm from WC, right? 100 mm from WC. But if I add all together, I can go with 100 mm only. But what will happen normally? They consider just a safety factor. They will say that to avoid any blockage, they will go with the next pipe size sometime, right? Say, for example, as an example here, you can see as a riser, if you go to local building code, what they say, up to 7 story, you can go with 100 mm, right? For the waste pipe and soil pipe. If you go to this
Mhm.
particular standard, you can see up to 7 story, you can go with the 100 mm for soil pipe and 100 mm for the waste pipe. Okay, but what they do, they just take a safety, they go with the they go they go with the 100 mm. Sorry, they go with the 150 mm, right? Just for the safety. Clear, right? Okay, so similarly, your riser pipe will go further down. Say, for example, if you go to another layout, okay, here it is going further down. Assume that this is my riser, or here it is my riser here. Yeah, assume that this is my riser, right? So this is a riser. So this riser again, what I will do, I will go directly to the nearest manhole in the ground floor. So whatever we have seen, say for example second floor, from the second floor below we have a riser pipe. Then from the riser pipe it is going down to the ground floor. Okay, from the ground floor, these all the pipes below the ground. It will be like buried pipes. Okay, so that pipe will be connected to the manhole directly, straight away to the manhole. Okay, say here you can see there is one accessory is called gully trap. Okay, so whatever the waste pipes, it will go to the gully trap, then again it will go to the manhole. What is the purpose of the gully trap? Say for example, we are using flow drains. We will put some waste paper, okay, or some of the dust, okay, or whatever the waste particles, it will be collected at the gully trap and it can be filtered. Okay, you can remove that whatever the solid particles you can remove before it goes to the manhole. Clear, right? And whatever the soil pipe or waste pipe, you cannot go with the gully trap because it is all human waste, right? So it has to go directly to the manhole. So you have a soil pipe will go to the manhole, and also your waste pipe also it will go to the manhole through the gully trap waste pipes. Is it clear up to here? So similarly, whatever we did exercise, you will do exercise for each and every space. Say for example, I have all the toilets here. So what we did, we have to collect each and every toilets or every accessories or every fixtures. It will be collected. You will reach to the nearest shaft. Okay. So here, what is that catch basin? What is the catch basin size? 110 mm. So you will run the pipe 110 mm. What is the flow drain? 75 mm. So you will run the pipe 75 mm. Right? Okay. Then you have a, say for example, you have a called butchery wash basin. So here you are going with a bigger trench drain. This is called trench drain, right? So here you can collect more surface water. Say for example, if you have a flow drain, you have to collect all the water to the particular position, right? Particular location. Okay, but if you have a flow drain, it can collect a major area. Quickly it can collect a major area, right? So this is what you are going with the trench drain. Okay,
Sir, one
so
question.
yeah, tell me, yes.
Uh, uh, I will go with the same question of FD. So suppose now our drainage fixture value according to IPC table is 2 DFU.
Okay,
Okay,
okay.
if we consider 5 floor drain, then the size will be 20. Means then we can move to 110 size from 75
Yeah,
because
yeah.
we achieved 20. Okay.
20, yeah.
Uh, yeah, but like when we will consider probable method after some means some engineers will I have seen they are converting after now we have 5 now they are converting after 8 FD to 110 means maybe they were considering this probable method.
Yeah,
They were.
see, I will tell you something. Okay, this
Mm,
depends upon the project to project. Okay, say for example, if you go to supermarket, okay, or like shopping malls, okay, so there the loading will be the people occupancy will be very high, right? The usage will be very high.
okay.
Okay, so there they will take a more safety factor. Okay, like they will increase the pipe size. Okay, say for example, in area like say for example, there is one office areas. Okay, office area where the people is very less. Okay, the usage of the toilet will be very less, right? So there you can add more number of fixtures. Okay, so
Ah,
that will vary depends upon project to project. It is not uniform everywhere. Okay, but
okay.
try to follow as per the standard. First priority, second priority, you try to analyze what is that, what is the usage method. Okay, whether it is a heavy
Mm-hmm.
usage or light usage. Okay,
Uh,
so based on the usage, you can increase the pipe size. If you increase the pipe size, what will happen? The client will ask, if the client having a technical, he is a technical guy, then he will ask, what did you consider higher pipe size? So you should have a justification why you considered higher pipe size because of the higher usage, right?
okay.
Okay, so that is depends upon the analysis. Okay, but always to go fixed as per the standard. What is the standard says? Go as per the standard because the standard is based on the research, right? Okay, if you are
Okay.
increasing above the standard, that means you are increasing the project cost. Should have a proper justification. Clear, right?
Mm-hmm.
Okay, you can increase any pipe size, but basically, if I have this particular area, okay, where is my shaft location? This is my shaft location. So how much fixture? How
No,
much
increasing the pipe size will be better for drainage, but like my question was,
decreasing?
after five, means
Yeah,
after five,
that is if you have a light usage, then you can decrease, right?
depend on usage, depend
Depends
on,
upon
yeah.
usage. See, where I have a high
Mhm.
usage, I cannot reduce my pipe size, right?
Yes.
Okay, so where I have a say for example, if you go to airport, okay, if you go to airport toilet, you can see that all the toilet is usage, right? If some flight comes
Uh-huh.
into the into after landing, you can see the toilet is full of people. Okay, so there you cannot apply like a lowest low level, right? You
Mm,
cannot connect more fixtures into that area. So there you have to go with the standard, or you have to go with the above the standard sometime because of the high usage, heavy usage.
yeah.
Okay, so
Okay.
that depends on case to case. Okay, so basically the pipe
And
size
in
is
this drawing, you have not shown any vent
no
connection.
vent is
Only
here, right?
single vent,
VP vent
single
pipe
thing.
is here,
Yeah, yeah. Only
vent
one
pipe is
blue
here.
one, but not from every fixture. Some projects.
Uh, See, that is also again depends on project to project. Okay,
Mhm.
you can provide if you need to provide vent drain, you can provide. It's not a problem. See, you not to consider only exactly this drawing. This is also prepared by same like as one engineer, right?
Mhm.
Okay, so you can increase the waste wherever you can do the analysis. Say, for example, I am expecting some waste, some smells from here, so I can use the vent pipe from here. You can connect vent pipe. You can provide one vent pipe to this area. Just adding one pipe to this area, adding one pipe to this area, right?
Mhm.
So it is as an engineer to engineer, you can decide. It's not simply to follow this drawing, right? Clear, right?
Yes.
Okay, so now this week we have talked about completely about drainage pipe size. So next week we will go to the vent pipe size. How to calculate vent pipe
Uh,
size depends upon how many fixtures, what is the length. We will see. As that is also
then
given in the standard. Clear, right?
yes.
So once we complete everything, vent pipe and wastewater pipe, everything, then we will go to the manhole area. How to size the manhole, right? Okay,
Mm-hmm. Yeah.
clear, right? Then after that we will connect all the manhole. Then it will be go. It will final pipe will go to the sewerage, the final FIC chamber. Clear,
Mm.
everyone?
Mm. Yes.
Okay, Rias, it is very simple method. Very simple. You have to try to find out what is the source of water, what is the type of water. Then you have to segregate. Okay, wastewater separate. Then you have a soil water separate. Okay. Then you have to calculate the drainage fixture unit calculation. Then you have to see the local standard and you have to see the international standard. Then you have to determine the usage, whether it is a light usage or heavy usage. Depends upon that, you have to decide the pipe size. So based on the pipe size, you will run all the pipes collecting from all the fixtures. Then you will try to go to the shortest path, right? You will not choose the longest path. If you choose longest path, then because of the invert level, you cannot reach some of the area, you cannot reach the false ceiling level. Okay, so you have to reach which is the shortest path to reach the shaft, to reach the nearest shaft. Okay, so that is what whenever we are with a consultant, we will try to find out where is the nearest shaft. Okay, where at all it is possible, we will try to find out inside the toilet itself the shaft. That is the first priority because that is the very shortest path. Okay, in case you cannot provide the shaft in the toilet, then you will try to find out the nearest area, the shortest path. Okay, so then it will go to the ground floor. Then from the ground floor you will go to the manhole. Then from the manhole you will try to reach to the FIC chamber. So that is the quickest path you have to find out to reach the gravity level, right? I think hope all clear, right? Ajit,
Yes.
Riyas. I think Aditya is a plumbing background. He can able to understand.
Yeah.
And other Riyas and Ajit. Ajit also plumbing background, right? Okay. So I think next week
Yes,
we
sir.
will talk about vent piping, right?
Okay.
Okay. See you then. I will be sharing the materials today. So hopefully you can start reading. It is similar to water supply. How we do what we did the water supply. The same principle will be applied for the drainage as well. Okay. But make sure you can do the sizing, because whenever you are preparing the drawings, like there are some like Ajit and Aditya, you're a beam person. Whenever you try to do the proper drawings, just whenever you are working, try to understand that whatever the pipe says is based on this particular one. Just do not think that you're copy paste from the IFC drawing or copy paste from somebody based on some information. Okay, whenever you do the drawings, try to analyze. Okay, this particular pipe, why I am considering 100 mm, why it is not 50, 150, why? So that type of analyzation should be there after this training, right? That is what I'm expecting.
Yes, yes.
Clear, right?
Okay.
Okay. Thanks. We will see you next week. Thanks, everyone.
Thank-
Thanks. Bye.
Okay, sir.
Yeah, thank you, sir.
Yeah.
Thank you.